Hi, and welcome to 4.06 Honors Stoichiometry. These are the Common Core standards that we are applying to this lesson. The lesson objective is to use the mole ratio and density to solve stoichiometry problems. There are previous material, previous lessons that are required that you have mastered. And ultimately, stoichiometry, the regular lesson to 4.06, you must have mastered it completely. If you haven't, stop, do not continue with this recording and go back to 4.06. The general flowchart for basic stoichiometry, and this is straight out of your lesson to 4.06, what we want to do is when you are given a problem, we want to see, okay, what are you given? Where do you need to go? We're going to mark our starting and our final destinations, and we are going to map out our route. That's all 406 regular information. For honors, we're now going to include density. So we need to think about where density will fit. Density equals mass divided by volume. Well, of these three variables, which one can be helpful with our stoichiometry flowchart? If you said mass, you are correct. Density is an extension of mass. So oftentimes we are given density or maybe volume, and then we have to solve for the mass first, and then we start mass of A here. So oftentimes we will need to use a density formula with the volume to get the mass of our chemical so that way we can start our flowchart. Here's a quick review problem from 4.06. I would like you to take out your periodic table, your calculator, a scratch piece of paper, and a pencil or pen, and please go ahead and pause this recording now and get as far as you can. How many grams of NH3? So it says how many grams are produced from 10.4 grams of hydrogen. So we're given 10.4 grams of hydrogen. Since we're given a specific amount of hydrogen, that is our first chemical, which we're going to call A. NH3 is the second chemical, we're going to call that B. Now in our flow chart, we are starting at A. Therefore, that is our mass of A. That's where we're starting. And then the question asks for grams of NH3. That is my ending or my final destination. So I'm starting with mass of A and I'm converting to moles of A. Once I have moles of A, then I have to make the long jump to moles of B. That's step number 2. Once I have moles of B, then I can convert to mass of B, which is step number 3. So this is a 3-step problem. Remember from 4.06 regular lesson, anytime you have grams of one chemical and you need to convert to grams of another, it will always be at least 3 steps. So we have mass of A. Remember, we start with what we are given, 10.4 grams of hydrogen gas. We put our X, we put our line. Whatever unit we start with, that's the unit that we put on the bottom. Using our flowchart, it tells us that we must divide by the molar mass. We already knew that because we already have grams on the bottom. Recall the definition of molar mass from lesson 2.04 and 3.09 and a little bit in 4.06 regular that we reviewed. The molar mass is the mass in grams of 1 mole of your substance. We go to the periodic table and we add 2 hydrogens together, which gives us roughly 2.016. My units of grams of hydrogen cancel. My unit that I'm left with is mole of hydrogen. That is not what the question asked for. Therefore, I'm not done. I put an X, I put another line. Whatever unit I have left up top here, I put that same unit down here. Now I have moles of A. When I have moles of A, if I follow my flowchart, it tells me to write this ratio. I'm going to put mole of my B chemical. Now remember, what was B? Our second chemical is a chemical the question asks for. And so that is going to be NH3. Remember from 4.06 regular lesson that the mole ratio are the coefficients in the balanced equation. We go to the balanced equation and we get those big numbers out front. NH3 has a number 2, H2 has a number 3. My units cancel. I'm left with moles of NH3. Still not what I was asked for, therefore I'm not done. I put another X, I put another line. My units that I have up here, that's the same unit that I put down here. Now that I have moles of B, I'm going to convert to grams of B by multiplying by the molar mass, which I knew molar mass was going to be up top because we had moles on the bottom already. Remember that the molar mass is the mass in grams of one mole of your substance. Mass in grams of 1 mole of your substance. When we look on the periodic table, we roughly get 17 grams per mole for NH3. My moles of NH3 cancel. I'm left with grams of NH3, which is exactly what the question asked for. Therefore, I'm done. I put an equal sign. And now what I'm going to do is multiply everything on the top. So I have 10.4 times 1 times 2 times 17. Then I'm going to divide by 2.016. I'm going to divide by 3, divide by 1, and my calculator gives me 58.465608. We are smarter than our calculators, so we go back to our problem. We see that my measurement has 3 significant figures. Therefore, my answer can only have 3 significant figures. I go to the next digit just to see if I need to round up, and I do. Therefore, I'm going to report 58.5. And yes, we are going to include our units and the chemical. A number without a unit is meaningless. If you really struggled doing this problem, you are not ready for 4.06 honors. Please go back to 4.06 and learn the regular lesson. In this lesson, 4.06 honors, we're going to be doing all those same type of stoichiometry problems. We may have to convert grams of one chemical to grams of another, just like we did, or moles of one chemical to grams of another. In the honors version, we're now going to see how density with mass and volume, how we can, and so some of our problems are going to be even longer. We may have to do an extra step before we can use that diagram for converting grams to grams. We must understand that density is mass divided by volume, and we can rearrange that formula. Mass equals density times volume, and we can even rearrange it to be volume equals mass divided by density. So depending on what you're solving for, which formula you need. The volume units that we typically see are centimeters, centimeters cubed, milliliters, and liters. Some of you may be asking, centimeters isn't a unit, and isn't a unit of volume. And you are correct. Centimeters isn't really a unit of volume, but oftentimes if we get centimeters times centimeters times centimeters, and that is why I included it here. Because you can have a problem where you are given length times width times height. And so even though centimeters is actually a unit of length, we need to remember that we can use it to get volume. So we can use centimeters to get volume. Even though centimeters is not by itself an actual unit of volume, we can use it to get volume. Some conversions that we need to remember. 1 liter equals 1,000 milliliters, and that 1 cubic centimeter equals 1 milliliter. Volume of a cube. You will have a problem where you have to calculate the volume of a cube. Volume of a cube equals length times width times height. So you could end up with a problem where it gives you, a cube has, 2.0 centimeters times 3.5 centimeters times 4.5 centimeters. How many grams of your product will you make? That can be really crazy at first. So just remember, we have these conversions that we might need to do kind of like on the side, and then we can do our stoichiometry. We might have to do these conversions first, we might do the conversions last. It all depends on what information they give us to start with, what information they give us to finish with. Let's go ahead and do this problem together. So what I would like you to do is on your scrap sheet of paper, go ahead and get as far as you can. Write down the information that you know. Make a list of what you know. Put the information about the specific chemicals over here, like I do. Make a list of what you know. Get as far as you can. Circle where you're starting. Circle where you're finishing. What extra information do we have? Get as far as you can, and then come back to the recording and we'll work through it together. Okay, looking at the problem, it says how many moles of iron 3 chloride, so this is iron 3 chloride, so it's asking me how many moles are needed to produce 31 milliliters of iron. 31 milliliters of iron. The density of iron, so it's given me the density of iron is 7.87 grams per milliliter. That's crazy. Now I have all this extra information. Notice the units for density, grams per milliliter. It's asking me to report my final answer in milliliters. Can you see how we might be able to use density to convert grams to milliliters? So they're giving us 31.0 milliliters of iron. That is going to be my starting problem, my start point. It's asking for moles of iron 3 chloride, therefore that's my final destination. 31 milliliters. I don't see anywhere on here anything about milliliters. I can't start. It's not on my chart. That's okay. So what we have to think about is how can we convert 31 milliliters to something that is on this chart? And that's what it tells us. We're starting with 31.0 milliliters of iron. It's not on this chart, so that means we have to do a conversion before we can do our stoichiometry. So 31.0 milliliters of iron. Remember that the density of iron is 7.87 grams per milliliter. Remember that conversions can be written either way, 7.87 grams per 1 milliliter. It just depends which way you need it. Remember with dimensional analysis, it's the same. Can we use density to convert milliliters to grams of iron? You betcha. So we have milliliters of iron. We're going to put an X. We're going to put our line. The unit that we start with is the same unit that we put down here. We have milliliters. Well, we have this unit for density of our iron, so it's 7.87 grams of iron per 1 milliliter. My milliliters of iron cancel. I have grams, and guess what? I now have grams of my A. If you wish, you could put an equal sign, figure out how many grams of iron you have, which I will go ahead and do. Or you could always just put an X, a line, and just start your stoichiometry. If you're a student that likes to have everything in one row, go for it. If you're a student that kind of likes to take the individual steps, you might want to do it this way. So we have 31.7.87, and that equals 243.97 grams of iron. I am not reporting this as my final answer right now, so I'm not going to worry about significant figures. Okay, so that is my mass of iron. If you want, you can go ahead and write it here, okay, because that's how much iron I have. So now I know my mass of A is 243.97 grams of iron. It's asking me to convert to moles of B, which is right here. So therefore, when I start with my mass of A, I'm going to convert to moles of A. Then, once I have moles of A, I'm going to convert to moles of B. And guess what? Now, this problem is exactly like the problems in 4.06 regular. Start with what you're given. Well, I was given 31 milliliters, but I got to start with something that's on the stoichiometry graph. So I did my honors conversion, and now I have 243.97 grams of iron. So that's my new starting point, 243.97 55.97 grams of iron. And now I'm here on my stoichiometry graph. So I'm going to put my X, I'm going to put my line. Whatever unit I start with, that's the unit that I finish, or excuse me, whatever unit I start with, that's the unit that goes down here. Be nice if we were already finished, right? And when we have molar mass, when we look at this flow chart, it says that we're going to divide by the molar mass. We already know that because grams are on the bottom. Molar mass, remember, is the mass in grams of 1 mole of your substance. We look at the periodic table. We see that the mass of iron is 55.845. My unit of grams of iron cancel. I'm left with moles of iron. That is not what the question asked for, so I'm not done. I put an X, I put another line. Whatever unit I have on top here, I'm going to put on bottom, moles of iron. My next step, once I have moles of my first chemical, now I'm going to multiply by the mole ratio to get to B. So I'm going to do moles, and now I'm going to put the second chemical, the chemical that the question is asking me to solve for. The question is asking me to solve for moles of iron 3 chloride. So that is the chemical that goes here. Again, remember, our mole ratio, that's the coefficients in our balanced equation. Go to your balanced equation. Uh-oh! Look at our equation. It's not balanced. Remember, you have to make sure that you have a balanced equation. I have 3 chlorines on the left, 2 chlorines on the right. Therefore, I need to get those balanced. I now have 2 irons on the left. I need to have 2 irons on the right. Now I'm balanced. Now I can plug in my coefficients. My units of moles of iron cancel. I'm left with moles of iron 3 chloride. And that's what the question asked me for, so I'm done. I put my equal sign. I'm going to multiply everything on the top. So 243.97 times 2 divided by 55.845 divided by 2. And my calculator spits out this lovely answer. 4.3686991. However, we are educated, we are smarter than our machine. Therefore, we know to look at the measurement in our problem, which was 31.0, and we're going to apply significant figures. Densities are not considered part of significant figures. Conversion factors, densities, things like that. Your measurement is what we use for significant figures. So 31.0 has 3 significant figures. Therefore, our answer should have 3 significant figures. We always go to the next digit just to see if we need to round, and we do. Therefore, the answer that I am going to report is 4.37. And yes, I want full credit for my answer, so I'm going to include my unit and my chemical. Technically, if you do not include your unit and the chemical, your answer is wrong, and honestly, you should not get any credit for it. So please make a habit of reporting your unit and the chemical. So this is one way that we have to use density. Sometimes you might have to use density first to get grams. Let's move on to another example. I would like for you to pause this recording and try to get as far as you can. Write down the information that you're given. Try to do the calculations. Try to map your route out. Do you need to use density first? Are you going to use density last? See if you can get as far as you can. Go ahead and hit play to resume this recording. The problem says, how many grams of water, oh, that tells me right here, how many grams of water, which since I don't know what that is, I know right away that's going to be my B, right? That's my final destination right here. How many grams of water will completely react with a block of manganese metal that is 2.5 centimeters by 3.5 centimeters by 2.0 centimeters if the density of manganese is 7.43 grams per milliliter? Uh-oh. That's a whole lot of information to write, isn't it? And so remember, we have to have something on this chart in order to convert to grams of water. So how can I use this information to get to mass? I need to know the mass of manganese. Okay, so starting off, the first thing I need to do is figure out what is my mass of manganese. What is the mass of manganese? I have enough information to be able to calculate that. The reason why I knew that I have to convert to mass of manganese is because it gave me this information, which is length times width times height, and it gave me the density. So basically it gave me the density, it gave me measurements that I can use to calculate the volume, which means I can solve for the mass of manganese. And once I have the mass of manganese, then I can start my stoichiometry here. Mass equals density times volume. My mass equals 7.43 grams per milliliter times my volume. Got to be very careful on my volume. And I'm going to go underneath the chart for this. My volume equals length times width times height, so it's 2.5 centimeters times 3.5 centimeters times 2.0 centimeters. So my volume equals 17.5, and since it's centimeters times centimeters times centimeters, that is centimeters cubed. Now be careful, because my density unit was given to me in grams per milliliter, which means I must convert centimeters to milliliters. And remember, I had that on a slide a couple of slides ago. And I said that 1 centimeter cubed equals 1 milliliter. Remember that whatever unit you start with, that's the unit that goes on the bottom. This is one of the easiest conversions to do. 1 milliliter equals 1 cubic centimeter. And so when we go back to our mass formula, we can plug this in. And we get 7.43 times 17.5, and we get a mass of 130.025 grams. That is the mass of manganese, which is our A chemical. Now that I have mass, I can start my stoichiometry. It is now a 4.06 regular chemistry problem. If you have 130.025 grams of manganese, how many grams of water can you form? The honors portion of this problem is over. So now we need to just solve the regular stoichiometry problem. Alright, so we're given that. Put our X, put our line. Whatever unit you start with, that's the unit that goes on the bottom. And we knew that because when you have mass of A, we have to divide by molar mass to get to moles of A. So molar mass, remember, is mass in grams of 1 mole of your substance. Please make sure that you look up manganese, which is in the middle of the periodic table, and not magnesium. My units of grams of manganese cancel. I'm left with moles of manganese. That is not what the question asked for. Therefore, I'm going to put my X, put my line. So I have moles of A. I'm going to make the long jump to moles of B. Whatever unit I'm starting with here, that's the unit that I put down here. My mole ratio tells me to put moles of my second chemical, which is the chemical the question is asking about up top. Again, we have to make sure we have a balanced equation. Let's double check. 1 manganese, 1 manganese, 2 hydrogen, 2 hydrogen, 1 oxygen, 1 oxygen. Awesome! Our reaction's already balanced. So we put the coefficients. This just happens to be a 1-to-1 ratio. Our mole of manganese cancels. We're left with moles of water. Still not the unit that we were asked for, so we are not done. We put another X, we put another line. Whatever unit you have up top here, that is the unit that you put down here. Once we have moles of B, we're going to multiply by the molar mass to get the mass of B, which we already knew that we're going to multiply because we had moles on the bottom already. the molar mass of water is 18 grams per mole. Remember, molar mass, 1 mole. Our units moles of water cancel. We're left with grams of water, which is what the problem asked for. Therefore, we're going to put an equal sign. We are going to multiply everything on the top. So 130.025 times 1 times 1 times 18. Then we're going to divide by 54.93. Divide by 1, divide by 1. Our answer comes out to be 42.607865, for which we are smarter than our calculator, so we are going to go to our units, our measurements, and figure out our significant figures. Notice that we had 3 measurements. So whichever measurement, remember we multiplied them, whichever measurement had the fewest number of significant figures is the number of significant figures that we use in our answer. Remember that from 1.07. We have 2 sig figs, 2 sig figs, 2 sig figs. Therefore, my answer should have 2 sig figs. And I go to the next digit just to see if I have to round up, and I do. Therefore, my answer should be 43 grams of water. And yes, you must include the unit and the chemical. Remember, we have to start with either mass or moles of A. If we're not given mass, then we have to find mass using the density. Now, sometimes we might have a problem where it gives us mass of A, we can convert to moles, or it gives us moles of A already. And then when we get down here, it wants to know how many milliliters of the B chemical can you get. So remember, you can always afterwards do density. Go ahead, hit pause, work this baby out. Get as far as you can. Welcome back. I hope you had fun working this out on your own. And if you honestly didn't even try, unfortunately, you're doing yourself a disservice. Once again, you can't learn stoichiometry and how to do these problems by watching me. You literally can watch me do 500 problems and you will not be able to do it on your own. It's like if I wanted to learn how to play piano. I can't just sit here and watch somebody else play piano. I could sit here and watch them play piano for 10 hours a day. And after 2 months of 10 hours a day, that doesn't mean I can sit there and do it myself. I have to actually try. You actually have to try. And if you honestly don't try, you're never going to get this. Don't expect to learn it if you're not trying. So please, give yourself the opportunity to learn this. It's not going away. You're going to use this in 407, 408, and all of Module 5 almost. So do yourself a favor and really learn 406. And if you did do this problem, awesome. You give yourself a pat on the back because that is fabulous. This problem says, how many grams of sodium hydroxide, all right, how many grams of sodium hydroxide will be formed by the single replacement reaction of 35 milliliters of sodium metal if the density of sodium is 0.97 grams per milliliter. This kind of looks familiar, doesn't it? Absolutely. So when we get to this problem, all right, so we have 35.2 milliliters. We know the density. This is going to be chemical A. And this is going to be chemical B because this is the chemical that we're asked for. How many grams of sodium hydroxide? That's going to be B, which means we're going to finish here. So where are we starting? I don't have grams or moles of A. Now this is the process that you want to think about. Can I get either mass or moles from the information given to me? And when we see the units, that will tell you. Density has a unit of grams in there. So I can use density and the volume to get me mass. So what I have to do is calculate density first, okay, use density to rearrange, solve for mass, and then I can start here. So writing down what I'm given 35.2 milliliters of sodium metal. I'm going to put my X, I'm going to put my line. Milliliters of sodium is what goes down here. And now once I have milliliters, I can use my density. Remember that density is 0.97 grams of sodium per milliliter. My units of sodium cancel. Now I have grams of sodium. Now I am here. Okay, so I'm here. Now I can convert to moles of A. I have grams of sodium here, so I put my X, I put my line. I put grams of sodium on the bottom. That's the molar mass. Mass in grams of 1 mole of your substance. The molar mass of sodium is 22.9. My grams of sodium cancel. Okay, so now I'm left with moles of sodium. Now I do the long jump to moles of B. So I put my X, I put my line. Whatever unit I have up there is the same unit that I put down here. Moles of A is on the bottom, moles of my B chemical, whatever the question is asking for. Okay, keep it simple. What is the question asking for? Sodium hydroxide. That's what you put up front or up top. Now remember your mole ratio, that's your coefficients in the balanced equation. Let's go back, make sure we have a balanced equation before inserting coefficients. I have one sodium, 2 hydrogen, a total of 3 hydrogen, 1 oxygen, 1 oxygen. Uh-oh, how can I get this balanced? Well, I'm seeing that I could probably put a 2 here, and that'll get me a total of 2 hydrogen plus 2 hydrogen, which is 4. I can put a 2 here to balance my 4 hydrogens. That gives me 2 oxygens. I have 2 oxygens. I have 2 sodiums. I can get 2 sodiums. So there we go. We're balanced. We look at the coefficients in front of these 2 chemicals, and we see that they're actually both 2's. My moles of sodium cancel. I'm left with moles of sodium hydroxide. That's not what I'm looking for. I'm looking for grams of sodium hydroxide, so I'm not done. I put an X. I put another line. Moles of sodium hydroxide are left on the top over here, so that's what I'm going to put down here. Once I have moles of B, I can now convert to mass of B by multiplying by the molar mass of that chemical. Notice it's the same chemical. Molar mass is always of 1 mole. So we look up on the periodic table. We add up the mass of 1 sodium, 1 hydrogen, and 1 oxygen, and we get roughly 40. My moles of sodium hydroxide unit cancels. I'm left with grams of sodium hydroxide, which is what the problem was asking for. Therefore, we're done. And voila, put an equal sign. And now we're going to do this very long math problem, and we're going to multiply everything on the top. So 35.2 times 0.97 times 2 times 40 divided by 1 divided by 22.9 divided by 2, and we should get an answer of 59.640175. That is what our calculator gives us. However, we're smart people, we're educated, so we know that we don't just write down what our calculator gives us. We go back to the problem, we look at the measurement that we were given. The measurement was 35.2 milliliters, has 3 significant figures, therefore our answer will be rounded to 3 significant figures. We go to the next digit just to see if we need to round, and we do not. Therefore, we have 59.6, and yes, the unit and the chemical are required as an answer. 59.6 grams of sodium hydroxide. The fourth and final problem. Please get as far as you can on this problem. Once again, if you only watch me do these, you will never learn stoichiometry. You will never learn how to use density with it. You must actually do the work. You must actually try these problems. If you don't expect to learn this. So go ahead and hit pause, and when you're ready to continue, hit play. Let's go ahead. It says how many milliliters of calcium metal. It's saying how many milliliters of calcium metal, which that tells me it's my B. That's my second chemical because it's asking me how many milliliters of calcium metal. With a density of 1.55 grams per milliliter are needed to react with 102.3 grams of oxygen. So 102.3 grams is my A. The question mark milliliters is my B. And there we go. So A, we're starting with mass of oxygen. And our final destination is not on this chart. Our final destination is milliliters. What do I need to do? Do I even need to do this chart? The answer is yes. Anytime you are given information about one chemical and asked to solve for another, you must do this chart. Notice how we are given the density of calcium. Remember that density has units of grams per milliliter. We can use grams to convert to milliliters. Therefore, if we could somehow figure out what the mass of calcium is, with the mass and the density, we could convert to volume. Because remember, volume equals mass divided by density, right? So if we know the density, which we do, and then we somehow find out what the mass is, then we can put them in here. Can I use the information given to solve for mass of calcium? Absolutely. In fact, we've been doing that several times because as long as we have mass of A, which is our oxygen, we can convert that over here to mass of B, which would be our calcium. So we're going to start with oxygen. We're going to convert to moles of oxygen. Then we're going to convert to moles of calcium. Once we have moles of calcium, we can convert to mass of calcium. And once we have mass of calcium, we can convert to volume of calcium by using density. So we're going to add an extra step. All right, let's start. Start with what you're given. My given chemical was O2. I was given 102.3 grams of oxygen. I'm going to put my multiplication sign. I'm going to put my line. Whatever unit you start with, that's the unit of your answer. That's the second time I've said that, isn't it? Whatever unit you start with, that's the unit that goes down here on the bottom. And if we use our flow chart, it tells us that we must divide by the molar mass. We know molar mass is on the bottom. We know molar mass is the mass in grams of 1 mole of your substance. So we must look on the periodic table, calculate our molar mass. It's O2, therefore there's 2 oxygens. Our units cancel. Left with oxygen, moles of oxygen. That's not what we're looking for, therefore we're not done. Put an X, put another line. We have moles of oxygen. Whatever unit we have there, we put that unit on the bottom. Now we have moles of A. Now we can multiply by our mole ratio to get to our second chemical. So moles of B will go up top. So that's moles of whatever the other chemical is that we're looking for. Now we're going to insert the coefficients. Remember, we need those coefficients in our balanced equation. Let's double check to make sure that we have a balanced equation. 1 calcium, 2 oxygen, 1 oxygen. Not balanced. And there we go. Now we look at our balanced equation. We see that calcium has a mole ratio of 2 to 1 for oxygen. Our units of moles of oxygen cancel. We're left with moles of calcium up top. Not what we were asked for, therefore we're not done. Put an X, put a line. Whatever unit you left with up top there, that's the unit on the bottom here. Once we have moles of calcium, we can now convert to mass of calcium by multiplying by the molar mass. We already knew we were going to multiply by molar mass because moles on the bottom already. We know molar mass is always grams of 1 mole. We look at our handy dandy nifty periodic table and we see that the molar mass of calcium is 40.08. Our moles of calcium cancel. We're left with grams of calcium, which in the 4.06 regular lesson, that's pretty much where we ended, right? That's it. But we're in honors. Therefore, we do more with this material. We are going to convert to milliliters. So we're not done. So we put another X, put another line. Grams of calcium are there. Grams of calcium are on the bottom here. Remember, we can convert mass to volume using the density. Density of calcium was 1.55 grams per milliliter. Now that's grams per milliliter. Our unit of grams is on the bottom, so we're going to have to divide by our density. Remember that your conversion factors can be written either way. Just make sure that you keep the correct number with the correct unit. It all depends on where you need it. So grams of calcium cancel. I'm left with milliliters of calcium, which is exactly what my problem asked for. And now I multiply everything on the top. So I have 102.3 times 1 times 2 times 40.08 times 1 divided by 32 divided by 1.55. 165.33 is the answer that you get. Now we look at our data. We were given a value of 102.3 that has 4 significant figures. Therefore, our answer should have only 4 significant figures. We are going to include our unit and our chemical. Thank you so much. It has been great working with you on honor stoichiometry.